Test-Driven Development, Part 1. Get inspired. Can you really be agile if you're afraid of your code? In this video, I hope to convince you that by practicing test-driven development, your team can feel confident to modify any code. We'll explore the relationship between software developers and the code they maintain and factors that slow us down. I will show you how things could be, what is possible, how your relationship with the code you maintain could be so much better. I hope to inspire you to want to learn more about test-driven development, to try it out, and to motivate others to experiment with it. So let's get started. Writing new code can be fun and exciting. Imagine you get to write a brand new application, or a web service, or an interesting feature. You get to start with a blank slate. You get to write it from scratch, the way you want it. Your design, your implementation. How exciting! But how about modifying legacy code? How do you feel about touching that old code that's already in production? It may be a little intimidating, don't you think? Maybe you're afraid of breaking it. Why do you think you may be intimidated of touching legacy code? Maybe the code hasn't been touched in years. You aren't familiar with this code. Someone else wrote it, and it's not easy to understand. You can't ask the developer that originally wrote it because they left the company a long time ago. You're on your own. Or maybe there's high risk to modify the code. What's in production works, and millions of people rely on it to manage their personal finances. The code is very complex, and its design eroded over time and accumulated technical debt. Breaking it risks damaging our reputation and losing customers. Modifying this code bears a heavy burden. Or maybe the legacy code uses old technology you're not familiar with. Or maybe you wrote it, but so long ago you forgot how it works or what you were thinking when you wrote it. The traditional way of working with legacy code provides you with this really nice incentive formula. Of course, I'm being sarcastic, but maybe you can relate to this. You ask yourself, does the code work? If the answer is yes, then you're good, leave it alone. If the answer is no, then did you change it? If yes, then you fool. Does anyone else know? No? Great, hide it. Yes, someone else knows? You poor thing. Can you blame anyone else? Yes? Oof, you're saved. No? You poor thing. There must be a better way of working. What do you think this does to our agility? If we're afraid to modify our own code, can we quickly react to changing customer needs or changing market conditions? Our team likely avoids modifying that old scary code. We'll do anything not to change it. We'll even wrap it up with more code just so we don't have to touch it. We just bury ourselves in more and more technical debt. And the more technical debt we acquire, the more difficult it becomes for us to make changes, and the slower we become. We could be practicing Agile really well. We could have an empowered team with a stable composition of people that decides on its own how much work to tackle. We may start our work with clear acceptance criteria. Our product owner may always be there for us when we need them. We may get really good at removing impediments and have very few dependencies on other teams. But if we're afraid of our code that we're responsible to maintain, it doesn't matter how agile we think we are, it's going to slow down our ability to roll out changes significantly. So I'll ask again, can we be agile if we're afraid of our code? So what do you think is causing this intimidation? For one thing, if we work the traditional way and break the code, we may not find out we broke it until much later, when someone else tests it down the road. So what? Well, by then, we already forgot how our code works, and we may need to waste time refreshing our memory to fix it. By then, our code is already integrated with our teammates' code changes. Our defects now affect others. Maybe they now need to modify their code too, because their code relies on how our code worked before we fixed it. By then, our commitments to the design and implementation choices we made are way deep. If we realize another way would have been better, it is now much harder to change it. Breaking legacy code may be more intimidating than breaking new features, because there's a bigger risk of backlash from customers. The reputational damage is bigger. Customers are already used to that thing working, and now we broke it. Also, when we work the traditional way and look at legacy code, it may not be apparent what it means for it to work properly. We may see something in the legacy code that looks funny to us and modify it, thinking we're cleaning it up, while really we just broke a usage scenario we weren't aware of. Someone must have spent a lot of time to bulletproof it from obscure usage scenarios, but we no longer have the memory on the team of what they were, and we can easily break them when we touch the code. That can be intimidating. There must be a better way of working, one that gives our team a higher confidence to modify any code anytime. So let's see what's possible. What could things be like if we worked differently? I will now open a development environment and show you how things could be. I will show you how confident we can feel to modify any code anytime. Remember, this video is about test-driven development. Right now, I'm not going to show you how to do test-driven development. I do that in a separate video in this series. Right now, I'm going to show you the positive effects of a team practicing test-driven development. I hope this will inspire you to try it out, as it has been proven to make a huge positive difference in a team's relationship with their code. So let's see what's possible. What things could be like for us. Here we are in a development environment. This is where a software developer writes code. This is where they spend most of their time. This development environment happens to be IntelliJ, and the code we're looking at is Java. Here we have some application code. This part is a method, a function, that does something. In our case, this method called isStrong tells us if a password is strong or not. Because our team practices test-driven development, when we first implemented this isStrong method, we actually wrote unit tests to drive our coding of this method and to make sure it works as we intended. Here are the unit tests that correspond to that code. These unit tests are basically code we wrote that use the isStrong method in our application in different ways. These unit tests make sure that the isStrong code works as expected. They validate that it behaves as we expect it to behave, under various conditions and scenarios. But they don't just validate the behavior, they also define the proper behavior. These unit tests define the scope of what the isStrong method does. So let's see what we can do with these unit tests. The magic is not just that these unit tests exist, it is what we can do with them. So right in here, in our development environment, where we work all day, every day, we can easily run our unit tests and see the results. As you can see down here, they ran in milliseconds, and they all passed. We can run them again and again as many times a day as we want, because they run so fast, and we can run them right in here inside our development environment where we code. This allows us to run our unit tests as we code. For example, let's say we're making some code changes, and as we're making them, we change this less than to a greater than. We can then rerun our unit tests, and look, 2 unit tests failed. We broke something, but that's okay, because we found out right away as we code. We can now fix it on the spot and keep coding. Let's say that in the process of coding some more, we accidentally delete these lines. At some interval as we code, we rerun our unit tests again. Oops, looks like we broke something again, but we don't sweat it. Why? Because we found out right away. Not just that, we also know the defects must be in the code we changed since the last time we ran our unit test. It is so much easier to find defects this way. So let's fix the problem and bring those lines back. Let's rerun our unit tests, and yes, verify everything works again. So think about it. We broke our code, we found out right away, and then we fixed it right away. We fixed it right away before we committed our code to version control, and other developers merged our changes with theirs. If on the other hand, we committed buggy code to version control, then our buggy code would have affected other developers' code, making for a bigger mess. Also, consider this. Right now, before committing our code to version control, if a defect we found through our unit tests leads us to rethink our design or implementation approach, then it's much easier to change course than if we attempted to change course after we checked it into version control and integrated it with the other developers' code. Let's see it one more time. We accidentally break our code again. Let's change the not equal to an equal to. Then rerun our unit tests. Look, we found out we broke something again. Now we can fix it right away. Let's put back the not equal to and rerun our unit tests. And voila, we fixed it. And we move on with our coding. Now let's do this. Let's say we need to completely re-implement this isStrong method. Maybe we need an implementation that runs faster, or uses less memory, or uses less lines of code to be less complex. Let's delete the entire implementation of the isStrong method. Normally, this would sound like a crazy idea. There's so much at risk. Besides the fear of breaking it, we don't even know what all functionalities, scenarios, conditions it currently handles. Our new implementation may miss something. But guess what? We have unit tests for this isStrong method. These unit tests don't just make sure it works as expected, they also define what it does. If our new implementation passes all these unit tests, then not only is the new implementation bug-free, but it means the new implementation also meets the definition of it being complete, done. It does everything we wanted it to do. It covers all the conditions and scenarios it is supposed to handle. Okay, so let's put in here a completely different implementation. This implementation accomplishes the same thing in only 2 lines of code. Now let's rerun our unit tests to see if this implementation passes all the scenarios defined by our unit tests. It looks like it passed 6 unit tests and failed 1. Okay, no problem. Let's refine the implementation and rerun our unit tests. Now it works. Do you see how much more confidence we can have to modify any code that is covered by unit tests? You may think, well, if I only had unit tests, but I don't. It would be crazy to try to go back and create unit tests for all my legacy code. You're right, that would be crazy. But listen, you don't have to. There's an effective strategy which basically says, if you touch it, then write unit tests for it. This strategy is very reasonable and works really well. I'll explain how it works and why it works in another video in this series. Unit testing has become such an integral part of how software developers develop code that modern IDEs come out of the box with great support for it. For example, as you can see in the IntelliJ IDE, the IDE recognizes which files contain unit tests and enables you to run them by clicking the play button next to their definition. You can run any one of them or run all of them. You can also run your unit tests and have it show their coverage over your application code. See here, it shows us that our unit tests defined in password test cover 100% of the code in the password class. And here, you can see more details about the coverage of our unit tests over our application code. I hope this video inspired you to want to learn more about test-driven development and to try it out with your team. Check out the other short videos in this series on test-driven development to continue learning in a fun way. You're off to a good start. Now continue your journey and have fun with it. If you like this video, then click the circle in the middle to subscribe and find out more about other videos.